So this is a video I have been, well, not a video, a lesson I have been very excited to do. And I'm upset that I'm having to do it over video and not in classroom. But, here we go. It's about Pokemon and the probability behind sequences of moves and abilities and etc. The new DLC has come out this week, so I've just been playing that. And this has got me excited to make this video even more. So, a few things to understand first for the people that haven't really played Pokemon ever. Moves have additional effects, so this is just a few examples, and they have a percentage chance of happening, so a 10% chance of dropping someone's statistics, or a 30% chance to flinch. They're just some examples. You can do all sorts. A lot of them inflict status like this, so burn, paralysis, freeze, poison. You'll see a few of them in the examples, but it's not important to understand that any of them at all, apart from that it's an effect. And flinching is kind of one that is on a lot of moves, as you can see here on Air Slash. It's where if you get flinched, you don't move that turn, so you kind of miss it. It's like a miss-a-go sort of thing, and a lot of our examples involve that. And a very quick disclaimer: if anyone is super cool and actually just does play Pokemon and understands about it, when you see some of the sequences of moves, you'll question my ability at Pokemon, but I just did it because they gave me the results I wanted for the maths questions. So I wouldn't actually be the moves I was going for. So let me grab my pen. First one, we'll just start with some kind of simple sort of tree diagram. So if you don't know, we've been studying tree diagrams at the moment, and the reason why this is because it links perfectly into tree diagrams, and it's probably the #1 application I do of probability outside of studying it and teaching it. And this kind of helped me plan my games when I play. So we've got a move here, Thunder. It's got an accuracy of 70%, and it has a 30% chance to paralyze. But the thing is, for it to paralyze, it actually has to hit first. So the real probability of it paralyzing on a Pokemon is not 30%. We can set up a tree diagram for this, so we can kind of ask the question, well, has it hit or miss? And then, has it paralyzed? So we can set up a two-way tree diagram, or just a tree diagram with kind of two events happening. And we're going to have hit, miss, yes for paralyze, no, yes, and no. The probability of it hitting is 70%, so that's 0.7. So the probability of it missing must be 0.3. Chance of a paralysis is 0.3, so for it not to paralyze must be 0.7, and same for the bottom branch. The branch we care about is, any branch that leads to a paralysis. So if we were to go down here, even though it's paralyzed, it's missed. So that's not going to paralyze. This isn't, it's just this top branch here. So going 0.7 and 0.3. So 0.21. So a 21% chance to para or paralyze, which is a considerable difference from 30% when you think about it in the case of if you need it to win. Okay, how about this one? If you can have a pause of the video and see if you can figure out the actual probability of Fire Blast burning an opponent. Okay, so in this, we're going to ask the same question. Are we going to hit or are we going to miss? And then we ask the question of a burn. So first, well, this time the accuracy is 85%. It's a bit more accurate. So our probabilities are going to be different here. And to balance it, being more accurate, it has a less chance of a secondary effect. So we're going to have 0.1 here, 0.9, 0.1, and 0.9. Again, we're looking for the same path. It's just going to be the hit and burn. These ones are not going to burn this one here because it's missed. It's not going to have any secondary effect if it's not got its first effect of hitting. So our probability is going to be 0.85 times by 0.1. This is going to be 0.085, so it's actually an 8.5% chance to burn. Let's have a look at this succession of moves. So we've got Pokemon Blacephalon, who was having a battle against Muk. He was using Shadow Ball, and Shadow Ball is 100% accurate, so we don't have to consider that. It's always going to hit. And it has a 20% chance to lower the target's special defense. And you can see, in successive turns, I have lowered the special defense. So we're just going to try and calculate, well, what is the probability of that happening? A lot of people that might still think it's 20% just because that's what the statistic says here. But we know that, well, we can set up turn 3 and turn 4. And this is going to be drop or not drop, drop and not drop, drop and not drop. And it's going to be a 0.2 for dropping because it's 20%. So that makes it 0.8 elsewhere. We want it to drop in successive turns, so we're concerned about this path here up to here. This one would only be 1. I mean, we could ask the question of what's the probability of it dropping at least once, and then we'd have to consider these 3 top paths. But we are concerned about it just dropping twice in a row. So this is going to be 0.2 times 0.2. That gives us to 0.04. So a 4% chance. So when I was doing that, I was very lucky for that to happen. And that can be something that really turns the tide in the game, because when you drop the statistics, it ends up you doing more damage. This is my absolute favourite interaction in the game. And you'll see on the next slide there's something else that they've introduced in a recent game like it. But Muk has an ability, Poison Touch, that gives him a 30% chance of poisoning when he makes contact, so when it's like a physical move like this. And he also has the move Poison Jab, which has a 30% chance to poison the target. So, taking into consideration Muk's ability and the move he's using, what is the probability of poisoning the opponent when you use this move? You'll see when we get the answer at the end why it's such a cool calculation. So I'm gonna first not gonna have a D there. I'm gonna have Poison Jab and Poison Touch. And this is going to be yes to poison and no to poison. Yes, no, yes, no. So the probability of it poisoning through Poison Jab is going to be 30%, so 0.3. And again, it's 30% for Poison Touch. Off the top of your head, and if you didn't know about tree diagrams and everything, you might just think 60%, or you might just think 30%, that they kind of just, I don't know, cancel each other out and don't combine. Or you might think 60% because they add together. But that is not the case. So we can either poison them with Poison Jab and poison them with Poison Touch. It doesn't matter if we poison them twice, they're still poisoned. We can poison them through the move Poison Jab and then fail to poison them through the Poison Touch. That still poisons them. We can fail to poison them through the move, but successfully poison them through our ability, Poison Touch. And this is the only one that's not going to poison them. So when we do our probabilities, we're going to do these calculations here. And when we get to that stage, we add these together. And that gets me 0.51. And why is that such a nice calculation? It's because it just tips it in your favour of happening, which is, it's just such a beautiful result, I think. Getting a 51% chance. It's just perfect. And you might also think, well, we could have done the probability of not poison, which is the bottom row, 0.7 times 0.7, and then done 1, take away that, and that would get us the probability of poison. And we can totally do that method, and we're going to see how that comes in handy in the next example. I'm not going to do this one, but this is the new thing they've introduced. So a new Pokemon, Melmetal, has got a move called Double Iron Bash. It has a 30% chance to flinch and it hits twice, and a 30% applies to each strike. So if you set up the tree diagram like we did on the last slide, you can try it yourself, you'll get to 51%, which is also really cool. Okay, this one. Cloyster, one of you, this is from like the first generation, so this is probably a Pokemon you know of. It has an ability skill link, which allows all multi-turn moves, so like Icicle Spear hits 2 to 5 times. Actually, skill link makes it always hit 5 times. So that's a good thing, that it has got some synergy between its move and its ability. The item that you can make it hold, King's Rock, gives moves that don't have a chance to flinch in their secondary effect a 10% chance to flinch. And the good thing is this applies to every single hit of Icicle Spear. So instead of it just being a 10% chance to flinch, well, we can calculate, well, what is its chance to flinch when it hits 5 times? People might just think, well, 10%, 20%, 30%, 40%, 50%, but we'll see it's not the case. It actually doesn't work as favourable for Cloyster as that. We can set up a tree diagram here. So, hit 1, hit 2. Can you see how this is going to get really, really, really awfully messy? That's going to be hit 4, and I'm not even going to bother drawing it for hit 5. If we just stop and think, if I have yes for flinch and no for not flinch, if we ever stop and think about what we want to calculate, well, once we flinch once, anything over that branches off from that, we don't care about, because it's flinched already. If you flinch, if you get flinches on 4 of them, it still just counts as 1. So as soon as we flinch, we want to stop. So then we'll follow down this path. Then as soon as we get to here, well, anything that comes past that, we don't care about again. And we can say that for all of them. So what we really want to do here is we want to calculate the probability of it not flinching, because that is the only path that we are not going to include. We're going to include everything that comes off here, everything that comes off there, everything that comes off there, everything that comes off there, and everything that comes off there. So you can see all we've got left is our 1, 2, 3, 4, 5 no's. And they are all going to be a 90% chance. Because 10% chance to flinch, so 90% chance to not flinch. So the probability of not flinching is 0.9 times 0.9 times 0.9 times 0.9 times 0.9. We could also just say that that is 0.9 to the power of 5 times. It's the same number each time. What that gets us is 0.59049. So the probability of it flinching is going to be 1. Subtract this. So roughly 0.41 minus these few decimal points there. So that is a 41% chance. I mean, it's not as good as the misinformed maths we did of just times in 10% by 5, but it's a lot better than having just 10% with the ability, with the item. So the item and the ability and the move all link together really well to make Cloyster, which wouldn't generally be a very good Pokemon without these sort of 3 things going together, makes it a really big threat. So we're going to go into some kind of games that I put together, and I've got a clip on the last one that we're going to watch. If we read this, so Scold is one of the most annoying moves in the game because it has a 30% chance to burn, but it feels like it has a 90% chance because it just burns me constantly, and it ruins some of your Pokemon when they get burnt. They lose half of their attack stat. But we can see in this interaction, I scolded and I didn't burn. I scolded and I didn't burn. And then I scolded and then I didn't burn. And then I got angry. Well, Bongard got angry. Let's calculate if I was justified to get this angry. What was the probability of this sequence of events happening? Well, we can have turn 2, turn 3, and turn 4. And we're going to have burn and not burn. Burn and not burn. Burn and not burn. And we're actually just going to we're not going to draw this final one on, we're going to think about what we actually need to draw. So, for burning is 0.3, for not burning is 0.7. Did I need to draw this top half of the tree diagram? Well, in the probability of this I never burned. So actually, all of this, if I burn on the first move, this is not the sequence of events I'm trying to calculate. And if I burn here, well, anything after that, I will have got a burn, so it's not the sequence of events I want. So I just want the sequence of events that says not, not, not. So the probability of not burning in my 3 moves is going to be 0.7 to the power of 3. So 0.7 to the power of 3 gives me 0.343. So a 34, roughly, % probability or chance. So I was kind of in my right mind to get a bit angry. But you'll see I continued that battle, and I ended up doing 7 scolds, and I didn't burn. And you can read that if you want a bit of me attempting to be funny. Schooling myself, I was both of the players. Schooling myself about tree diagrams. But from that, well, what is the probability of this sequence of events happening? I don't think I've ever done this before, hitting 7 without burning. But we can kind of imagine in our head it's just going to be 7 strands of no, isn't it? 1, 2, 3, 4, 5, 6. That is the path we're going to be caring about. All of these yeses, well, we don't care because that's not what we're trying to calculate. And they're all going to be 0.7. So the probability of not burning in 7 moves is going to be 0.7 to the power of 7, because we've got it 7 times. And you'll be surprised on how unlucky I was in this game. 0.082. So that was a roughly just above an 8% probability or chance of happening, and I hope that never happens to me ever again. Especially when I'm not playing myself and I'm actually playing a real match. Okay, this one and one final one, where we'll watch the battle for that one. When a Pokemon is paralysed, as you can see Kommo-o is, they have a 25% chance of risking full paralysis. It's basically like they miss a turn, they don't move. And when Jirachi goes for Iron Head, which generally has a 30% chance to flinch, with his ability Serene Grace, that doubles the secondary effect. So actually this turns to a 60% chance, so it's a pretty dirty tactic, and you just pray that you can keep hitting them and the opposition never moves, especially if you paralyse them before. And we'll see that when I did this, Kommo-o broke out. Did not para or flinch on the first try. And I was a bit annoyed, because I set all this up to just kind of chip him down with Iron Head. What is the probability of that happening? So, well, first we can say he could have stopped his move from paralysis. Second, we could have said he stopped his move from being flinched. And I'm going to have yes that he didn't move. Oh, yeah, and no. And no that he moved. So the probability of him not moving for a paralysis is 25%, so 0.25. And the probability of him not moving from the iron head flinch is 60%, so 0.6. And then we can fill these in with the probabilities that add to 1. And we're going to calculate the probability of him not getting flinched, so with him moving, so this one here, and not getting flinched or paralysed. And that is just going to be this bottom path. There. All of these, well, he would have not moved from paralysis and not moved from flinch, so he definitely didn't move. He would have not moved from paralysis, and then it wouldn't matter what happened with the flinch. And he would have moved, he would have got through the paralysis, but he wouldn't have got through the flinch. So, oh, I've got these, I've got this the wrong way around, sorry. Confused myself with the Y's and no's. Should have done it with flinch and not flinch, F and F dash or something like that. So this is the only path we want, where he moved. Oh, I got this all out of shape. My apologies. This is a terrible example. Now, ruined it, but I'm not recording it all again. 75% chance that he moved because it's a 25% chance that he didn't move. So I confused myself here. But still the paths is what I want. So I'm going to do 0.75 times by 0.4. And that is going to get me a very nice number of 0.3. So we only had a 30% chance there to move, which means I had a 70% chance for the move to go how I wanted it to. So I was unlucky again with what happened there. And then this final example. So I'll set it up. Same with Jirachi, so the same ability, the same Iron Head, not paralysed this time, so I don't need to take that into account. And we'll just watch what happened. And I'm going to put the music on, and it's very, very loud, so you might want to lower your volume. Okay, so he finally broke out there. But you can see I kind of got some of my luck back after proving that I've been really unlucky in all my other moves. I flinched him 1, 2, 3, 4, 5 times. And you're going to see how low of a probability this is. This happens all the time. I don't know why. There's something in the game that doesn't seem to do the probabilities properly. But flinching 5 times in a row, well, we can set up flinch and not flinch. The F dash means that dash means not. So the chance of flinching is 0.6. Chance of not flinching is 0.4. So we can think, well, all we care about is these 5 branches where it flinches. All the rest of this stuff is not what's happened in the game, so we don't bother wanting to even draw it because it's going to take too much time. So the probability of a flinch 5 times in a row is going to be 0.6 times 0.6 times 0.6 we can say that's 0.6 to the power of 5. And when I just quickly calculate that, well, that is going to be even smaller than the last probabilities we calculated, 0.7776. So that is roughly about a 7.8% chance. So, I don't know, swings and roundabouts with the game. You get unlucky by not burning 7 moves in a row, but then you get 5 flinches in a row. And there's a load more really cool interactions in the game, and hopefully as you learn more maths, you'll learn more stuff about it. Thank you very much for watching. I hope you enjoyed.